In the use case 6.8 of EOSC-Pillar, we work on the definition and implementation of a system defining and storing research data collections. The management of digital objects remains an area of interest that crosses disciplines, institutions, and infrastructures. In this context, the need for building aggregations or collections of such objects has become an essential element. Research data management practice requires not only to describe collections, but to make them actionable by automated processes to be able to cope with ever-increasing amounts and volumes of data. With standard data provisioning systems in seismology, users can define the contents of the dataset and create them on the fly. But the specification doesn't contemplate the idea of pre-assembled datasets. GeoFM, for instance, is providing more than 100 million user-defined datasets per year. It could be impractical, due to storage limitations, to replicate the requested datasets by keeping a copy of each of them. Therefore, there is no way for a user to reference the dataset for future use, for instance for publication or to share it with someone else. Today, the user can only share the request definition, but if data are modified, the resulting dataset will be different from the original one. The limitation with existing solutions for the management of data collection is that they focus on describing collections and their semantics with the metadata, but they do not offer a full set of generic machine actionable create, read, update and delete operations on them. That's when a working group of RDA decided to prepare the specification of a research data collection system to overcome these issues. From its specification, this system provides a formal API, collections that could be registered with persistent identifiers, PIDs of any kind, objects inside these collections that will be also identified by PIDs and may belong to more than one collection, and features like that a single collection that may contain objects from different sources, for instance different data centers, but one of the most important features is that collections will offer well-defined actions that can be executed by automated agents. The software is completely discipline independent and ready to be adopted by anyone. As it is per definition a lightweight system, a container with a ready-to-use version will be available and provided to anyone needing it. The goal is to make the data collection system generic enough and ready to be adopted by others within EOSC. Regarding the status of this task, we have already collected the requirements from the seismological community, we have implemented many improvements to the current GeoFM system, which is the base for the system to be delivered, and also we have collected some requirements from partners regarding implementation details. What we are working on now is on the evaluation on the feasibility to open it to more communities and use cases, to extend and improve the RDA recommendations, and to contact other communities as sub-use cases to foster system adoption. And still to be done is the implementation of non-standard requirements and the deployment of the system and the provisioning of a ready-to-use container.